So I want you to just imagine for a second that your life right now feels like an absolute disaster. Like today is just the worst.
Now, we've all been there.
Right. Maybe you, I don't know, missed a crucial flight, or you totally bombed an exam you spent weeks studying for, or you just got into one of those incredibly heated, exhausting
The
arguments.
ones that just ruin your whole week.
Exactly. And in that moment, your entire reality feels completely turned upside down. Like
Yep.
the world is literally ending.
It feels huge.
It does. But now, I want you to mentally pan the camera way, way out. Just zoom past your city, past the atmosphere, until all of that overwhelming human drama is just happening on this tiny pale blue marble floating in the middle of a completely silent infinite void.
Which is, frankly, it forces a hard reset on the brain. I mean, when you actually pause and contrast how massive our daily ground-level anxieties feel versus how microscopic they actually are on a cosmic scale, the perspective shift is, well, it's almost jarring.
Yeah, jarring is the perfect word. And that tension, that exact feeling, is the mission for today's deep dive. We are unpacking this incredible stack of sources detailing the legacy of the astronomer Carl Sagan.
Such a legend.
Truly. And we're looking at his work alongside the historical and scientific milestones that basically forced humanity to entirely rethink its place in the universe. We're going to explore, where we come from, how big this place really is, and how the scientific method evolved to give us these answers.
It's a massive topic.
It is. Honestly, reading through this material, I kept thinking about a movie set. Like, we all walk around every single day acting like we are the main character in this massive, high-budget blockbuster.
Oh, 100%.
But when you apply this cosmic perspective, you realize we're actually just background extras on a remarkably tiny set.
Which is the perfect entry point into Sagan's work, right? Because you can't really grasp how humbling that pale blue dot perspective is until you force your brain to look at the actual literal numbers of the universe.
And warning to the listeners, human brains are genuinely terrible at this.
Oh, completely. We did not evolve to comprehend the scale we are dealing with here at all.
We fail spectacularly at it. So let's try to break this down, because the sheer scale of the cosmos is genuinely crushing. Sagan pointed out that the universe is so impossibly large that miles and kilometers just become, well, utterly useless.
Right. They just don't work.
Yeah, scientists had to invent a brand new unit of measurement just to be able to write this stuff down without running out of paper, basically. And that's the light year.
And if you think about what that unit actually represents, I mean, light is the absolute speed limit of existence. It travels at roughly 300,000 kilometers per second.
Which is wild.
Just to visualize that, light could circle the entire Earth 7 times before you can even finish blinking.
Okay, so if you let that beam of light travel for an entire year, how much ground does it actually cover?
Roughly 10 trillion kilometers.
10 trillion.
Yeah. That staggering distance is just one single light year.
And here is the part that completely breaks my mind. It's the time travel aspect of stargazing.
Oh, this is the best part.
Right. When an astronomer says, hey, that star is 10 light years away, they aren't just giving you a physical distance. Because it took 10 years for that star's light to physically cross the void and hit your eyeball, you aren't seeing the star as it is right now.
No, not at all.
You are literally looking at a decade into the past.
Exactly. Every time you look up at the night sky, you are staring directly into history. You might be seeing the light of a star that actually burned out, say, 1,000,000 years ago.
That's just crazy to think about.
It is. And if we connect this to the volume of what's out there, the scale gets even more terrifying. We are talking about roughly 100 billion galaxies in the observable universe. Not stars, mind you. Galaxies.
Wow.
And each one of those galaxies contains about 100 billion stars and planets.
I actually did the math on that from the source material. It's a 1 followed by 22 zeros, so 10 to the power of 22 planets. And Earth is just like one single fragile rock in all of that.
It's unfathomable. So if the universe is that huge, it raises a really interesting historical question, right? When did we first realize we were just a tiny globe floating in this massive void?
Because we certainly didn't always know that.
No, definitely not.
I love this story, by the way, because I think modern people have a lot of arrogance about the past.
Yeah.
Like, we assume ancient people were just stumbling around in the dark, completely primitive.
But they knew nothing, yeah.
Right, and we assume we needed, like, modern satellites to figure out the shape of the Earth. But someone figured this out 2,000 years ago in Egypt, essentially doing planetary geometry with a piece of wood.
Eratosthenes. He was this brilliant Greek mathematician and the director of the Great Library of Alexandria.
The ultimate nerdy job.
Oh, absolutely. So he was reading a text about the city of Sagan, which is modern-day Aswan, and the text noted a very specific anomaly. On the summer solstice, at exactly noon, the sun was directly overhead.
Okay, so straight down.
Right. A vertical stick placed in the ground casts zero shadow, and sunlight reached all the way to the bottom of these deep water wells.
But Eratosthenes was up in Alexandria, and he noticed that at the exact same time and date, a vertical stick in the ground there actually did cast a shadow.
Which is, I mean, that's the spark of pure scientific inquiry. He looked at that and asked why.
Okay, let me play devil's advocate here for a second, because if I'm an ancient person, couldn't I just argue that the Earth is flat, but the sun is just, I don't know, really close and shining at an angle over Alexandria?
You know, it's a fair assumption until you factor in the math. See, Eratosthenes knew the sun was far enough away that its rays hit the Earth parallel to each other.
Ah, okay.
So if the Earth were flat, those parallel rays would hit both sticks at the exact same angle. Both sticks should behave identically.
Meaning either both cast a shadow or neither casts a shadow.
Exactly. The only physical way a parallel light source creates different shadow lengths at the exact same time is if the surface of the Earth itself is curved, which changes the angle of the stick relative to the light.
And he didn't just stop at, it's curved either. He actually measured the length of that shadow and the physical distance between the two cities.
Using geometry.
Yeah, and he calculated that every 800 kilometers, the Earth curves about 7.2 degrees. From there, he just multiplied it out to get the full 360 degrees of a sphere. So 2 millennia ago, with basically a stick and a shadow, he calculated the 40,000 kilometer circumference of the Earth almost perfectly.
It is a breathtaking leap of logic, really.
Yeah.
But here is the kicker with all of this. Even after Eratosthenes proved the Earth was a globe, our egos remained wildly unchecked.
Oh, of course they did.
Yeah, we accepted the shape of the Earth, sure, but we still stubbornly assumed that our little globe was the absolute stationary center of everything in existence.
We were just so desperate to feel like the VIPs of the cosmos. The sources point out that our ancestors initially used star patterns purely for survival, right? They watched the sky to predict the seasons, or to figure out when fruits would ripen, and to track animal migrations.
The sky was basically a giant, ultra-reliable clock.
Right. And because human beings are fundamentally wired to seek patterns, we interpreted that reliability in a very self-centered way. By the 2nd century, this scientist Ptolemy officially declared Earth as the unmoving heart of the universe.
And his logic was pretty intuitive, honestly. He basically said, look up, we stand still, and the entire heavens come and go in a perfect circle around us.
Which is what it looks like. And that geocentric view held for over 1,000 years. Nobody seriously questioned it because, well, it made us feel crucial to the grand design.
Until 1543, when the Polish scientist Nicholas Copernicus drops the absolute bombshell.
The ultimate cosmic demotion.
Yes, he publishes his mathematical models arguing that, hey, we aren't actually that special. The universe doesn't revolve around us. We revolve around the sun.
I mean, it's hard to overstate the psychological blow of that realization. It wasn't just like a tweak in an astronomical model. It was an existential demotion. Suddenly, humans were just part of a localized mechanical system.
But you have to ask, how did they actually prove Ptolemy wrong? Because if you go outside tonight and look up, it really does look like everything circles us.
So what was the flaw in the geocentric model?
It had a glaring problem that astronomers called retrograde motion. Occasionally, a planet like Mars would appear to slow down, stop, and actually move backward in the night sky for a few weeks before moving forward again.
Which is just weird.
Very weird. Ptolemy tried to explain this with incredibly convoluted math, suggesting planets did these little loop-de-loops as they orbited us.
Which makes no sense mechanically.
None at all. But if the sun is the center and Earth is orbiting it faster than Mars on an inside track, it makes perfect sense.
Oh, I see.
Think of it like passing a slower car on the highway. As you pass them, for a brief moment, they look like they are moving backward relative to your window.
That is such a good analogy. And that realization shattered the Earth-centric universe. Then, 60 years later, Johannes Kepler twisted the knife a little more by proving that planets don't even move in perfect divine circles.
Right, they move in messy ellipses or ovals.
Exactly. And Kepler also realized the sun had some sort of magnetic force attracting the planets, which totally laid the groundwork for Isaac Newton to later discover gravity.
What fascinates me about all this is how human psychology adapted. Once we finally accepted we were just another rock circling the sun, we immediately started projecting our own human stories and myths onto the other rocks in our solar system.
We just couldn't help ourselves. The Romans named the planets after their gods based on how they looked. Venus was the bright, beautiful goddess of romance, and Mars was the blood-red god of war.
But the physical reality of these places is just a brutal, inverted joke.
It really is. Venus has to be the worst romantic getaway in the history of the universe. I mean, if you were listening to this deep dive on your commute right now, just look out the window. Every tree, every puddle, every breath of air you see is an absolute statistical anomaly in a universe that is actively trying to freeze or melt you.
That is so true. And Venus is the ultimate example of that. It is literally hellish. Because of its proximity to the sun and its suffocating atmosphere, the surface temperature sits around 480 degrees Celsius.
Good grief.
Right, the clouds are made of sulfuric acid. The atmosphere is 96% carbon dioxide, which creates this runaway greenhouse effect.
Yeah.
It acts like a planetary pressure cooker hot enough to melt lead.
And then there's Mars. We are still deeply obsessed with Mars today. I mean, you have billionaires openly discussing building colonies there. It has ice caps, dust storms, a 24-hour day.
It feels familiar.
Exactly. But the historical obsession is even wilder. In the late 1800s, an American astronomer named Percival Lowell looked through his telescope and confidently claimed he saw water canals on Mars.
Oh, this story's wild.
Yeah. He genuinely believed there was a dying civilization out there, building massive irrigation systems to survive.
And it is such a poignant example of pareidolia, which is our tendency to see patterns that just aren't there. Those quote-unquote canals were just an optical illusion. They were caused by the poor optics of his telescope and, interestingly, the blood vessels in his own eye.
Wait, he was just looking at his own eyeball.
Basically, yeah. But we wanted so badly to not be alone in the dark that our brains literally drew lines connecting blurry dots to form a story of a neighboring civilization.
That is tragic and hilarious at the same time. The modern reality, though, is that Mars is a barren, frozen desert where temperatures hit minus 80 degrees Celsius.
Pretty hostile.
Yeah, but there is water ice. The source material notes that if we could eventually figure out how to melt that ice, extract the oxygen, and build pressurized habitats, the only Martians in the future might actually just be us.
Which naturally pushes the horizon out even further. If Mars is barren and Venus is hell, what about the rest of those 10 to the 22nd power planets? Are we entirely alone? And if we aren't, how on earth do we say hello?
Okay, but if there are really that many planets, why haven't we bumped into the classic Hollywood aliens? You know, the green skin, the big eyes, essentially just humans wearing a sci-fi filter. Doesn't the math say they should be out there?
Well, Carl Sagan argued very strongly against that Hollywood depiction. Life is a direct product of its specific environmental conditions. I mean, just look at Earth. We have everything from microscopic tardigrades to blue whales to oak trees.
The diversity is insane.
Right. So if an alien planet has different gravity, a different atmospheric composition, or different radiation levels, whatever evolves there would likely be completely unrecognizable to us.
The sources mention Sagan's theory about life on a gas giant like Jupiter, and it is so out of the box. Like, Jupiter doesn't have a solid surface.
Right, it's just storms and gas.
So he theorized that life there might be massive, kilometer-wide living balloons floating in the atmosphere, perhaps generating energy through some biological process similar to photosynthesis.
Which really highlights how narrow our definition of life can be. But it brings up a massive logistical problem. If we are trying to communicate with floating space balloons or subterranean microbes, we wouldn't just, shake hands.
Definitely not.
Sagan pointed out we would have to use radio waves since they travel fast and far. But more importantly, we would need to use a universal language.
Specifically mathematics. The idea was to broadcast a sequence of prime numbers, like 2, 3, 5, 7, 11, which made me stop and wonder, why prime numbers? Why not beam out a beautiful piece of music or a painting to show them what we are capable of?
Well, art is incredibly subjective. A painting or a song means absolutely nothing without the cultural context of the human who made it. An alien wouldn't have the biological hardware to process a symphony the way we do.
That makes sense. They might not even hear sound.
Exactly. But physics and math are the only guaranteed shared realities between us and a completely alien species. Prime numbers, numbers divisible only by 1 in themselves, are an undeniable, objective, cosmic constant.
So it's foolproof.
Totally. Receiving a sequence of prime numbers wouldn't be a greeting. It would be an unambiguous mathematical signal saying, we are here, we possess intelligent logic, and we understand the fundamental rules of the universe.
Basically, we are here and we are smart. But interestingly, we haven't just relied on math. We've actually thrown a physical message in a bottle out into the dark.
Oh, the Voyager probes.
Yes, in the 1970s, NASA launched the Voyager 1 and Voyager 2 space probes. They're currently the farthest human-made objects from Earth, and they're powered by decaying plutonium. And Sagan helped design a project to go on them called the Golden Record.
It is a literal 12-inch gold-plated copper phonograph record sent into deep space,
Yeah.
a cultural time capsule.
But wait, how would an alien species possibly know how to play a vinyl record? I mean, they don't exactly have turntables just sitting around.
Sagan thought of that. The outside of the record's aluminum jacket is actually etched with symbolic binary language instructions. They explain the origin of the spacecraft and indicate exactly how the record is to be played.
Oh, wow.
Yeah, they even included a cartridge and a stylus right there on the probe. If an alien species is advanced enough to intercept a probe in deep space, they will possess the physics knowledge to decode the visual instructions and build a device to spin it at the correct speed.
That is just incredible. And what's on it is designed to show our absolute best selves. It has greetings in 60 different languages. It has the sounds of wind, thunder, and humans laughing. It contains a map of our solar system and a schematic of our DNA.
It's beautiful.
It is. But what I found profoundly moving is what Sagan chose to leave out. He purposefully excluded images of our wars, our poverty, and our nuclear weapons. He wanted our very first impression on the universe to showcase our beauty and our potential.
A deeply optimistic gesture. But, to truly appreciate how humanity got from worshiping the stars to launching gold records into the void, we really have to look at the philosophical engine that made it possible. And it's an engine that was brutally stalled for 1,000 years.
This part of the history honestly blew my mind. Because the true roots of this scientific awakening didn't start in Renaissance Europe. They started in Ionia, in modern-day Turkey.
Right, the ancient traders.
Yeah, the Ionians were interacting with the Egyptians and the Babylonians, who all worshipped completely different pantheons of gods. And because of that exposure, the Ionians had this incredibly rebellious thought. They said, if everyone has different gods claiming to control the exact same sun and rain, maybe it's not gods at work at all.
Yeah.
Maybe there are natural physical laws running the show.
Removing the supernatural to look for the mechanical, that right there is the birth of the scientific method. And it led to astonishing, almost prophetic leaps.
Like Democritus.
Yes. Around 430 BCE, the philosopher Democritus conceptualized the atom. He imagined cutting an apple and argued that the knife was simply passing through the empty space between tiny, indivisible particles of matter.
Wait, he figured out atoms with just a theoretical apple.
Theoretical apple, yeah.
Yeah.
He mapped out atomic theory 2 millennia before science possessed the tools to actually prove him right.
But then progress just hits a brick wall. And the shocking irony is that the people who threw up the roadblock were some of the most revered historical giants. Pythagoras, Plato, and Aristotle.
Yeah, they had a very rigid belief that the universe was purely divine and mathematically perfect. Because of that, they actively discouraged physical experimentation.
They literally held us back.
They did. They argued that getting your hands dirty with physical tests was unreliable and, well, beneath the purity of philosophy. Pure thought, they claimed, was the only legitimate path to the truth.
And when Christianity arrived, it heavily reinforced this idea of a perfect divine universe that shouldn't be poked or tested. So for a millennium, science was largely suppressed. People were simply afraid to experiment. We just sat on our hands.
Until the Renaissance hits in the 1500s. That Ionian spirit of physically testing reality is finally reborn. You get Galileo dropping weights from the Leaning Tower of Pisa, proving that in a vacuum, objects fall at the exact same speed regardless of weight.
Which ultimately paves the way for the 20th century, where Albert Einstein brilliantly merges those two competing philosophies.
The perfect synthesis.
Exactly. He takes the pure, abstract thought experiments of Plato and applies them to the strict physical laws of the Ionian tradition to basically break physics wide open.
Let's unpack Einstein's famous thought experiment because it fundamentally alters our understanding of reality. Imagine you are in a car driving 100 kilometers per hour, and you throw a baseball out the front window at 20 kilometers per hour.
Okay, I'm with you.
To someone standing on the sidewalk watching you drive by, that ball is traveling at 120 kilometers per hour. Just basic addition.
Sure. Speeds add up.
But Einstein realized that this everyday logic completely shatters when you apply it to light. If you are in that same car going 100 kilometers per hour and you turn on your headlights, the light shooting out of those bulbs does not travel at 300,000 kilometers per second plus the speed of your car.
Wait, why not? I mean, if I'm moving forward, shouldn't the light get a boost from my momentum?
It doesn't. The speed of light is a hard, absolute limit. It is exactly 300,000 kilometers per second, no matter how fast the source is moving and no matter how fast the observer is moving.
But if the speed of light is locked, and it can never speed up or slow down, something in that math equation has to give.
And that something is time and space. Einstein concluded that time and space are not a fixed, rigid backdrop. To keep the speed of light constant, time literally has to slow down, and physical space has to compress, depending on how fast you're moving.
Time bends so light doesn't have to.
Exactly. That is the core of relativity.
It's just wild to wrap your head around. And that awakened, rebellious urge to test the universe inevitably propelled us off the planet altogether. The source material highlights how the space race, driven by the geopolitical tension of the Cold War, finally pushed us out of the cradle. We launched satellites, we put Yuri Gagarin in orbit, and eventually, Neil Armstrong walks on the moon.
But beyond the politics and the posturing, Sagan often pondered the deeper why. Why spend the immense resources to go out into the void?
Right. What's the point?
He believed that science is fundamentally a perspective. It forcefully shrinks our petty terrestrial conflicts. But simultaneously, it highlights just how incredibly special Earth is. As far as we currently know, this pale blue dot is the only place where matter has evolved to dream, to write, and to think.
And it requires so much humility. The text points out that true scientists actually love being proven wrong. Finding out you're wrong is a victory because it means you just eliminated a false path and got one step closer to the truth.
It's a very healthy mindset.
We desperately need that humility because the great unknown is still staring us right in the face.
It is. Everything we have ever observed, every galaxy, every star, every planet, and every atom we have ever measured makes up only 5% of the universe.
Wait, only 5%?
Yeah. The other 95% is invisible dark matter and dark energy.
It's like we've been spending our entire lives studying the actors on a stage, meticulously writing down their movements, only to suddenly realize that the stage, the curtains, and the theater itself are made of invisible stuff that is steering the actors around without them even knowing. We've barely dipped our toes in.
Which means true science isn't about having all the answers. It's about being comfortable operating in the dark. From Eratosthenes drawing lines in the Egyptian sand to the rovers currently drilling into the surface of Mars, the driving force has always been a relentless curiosity.
Sagan had this beautiful, profound realization about that specific curiosity. He famously said that we are made of star stuff.
Such a famous quote.
Yeah, because the literal atoms in our bodies, the iron pumping through your blood, the calcium in your bones, were forged inside the fiery cores of ancient stars that exploded billions of years ago. So when you look up at the night sky, you aren't looking at some cold, disconnected void. You are looking directly at your own origins.
We are not just some insignificant piece of debris in the universe. We are the part of the universe that has developed the biological architecture to think, to wonder, and to ask questions. We are, quite literally, the way the cosmos knows itself.
So what does this all actually mean for you? I want to leave you with a final thought to mull over today. If we are literally constructed from the universe, and we possess this relentless, agonizing drive to map, measure, and understand that universe, doesn't that mean human curiosity isn't just some quirky personality trait?
It's something bigger.
What if our urge to do science, our need to explore, is literally just the cosmos attempting to look in the mirror and finally wake up to its own existence?
That is a staggering thought.
It is something to think about the next time you feel overwhelmed by a bad day, or the next time you happen to catch a shooting star. Remember the pale blue dot. The universe is out there, and you are an active, thinking part of it. Catch you on the next deep dive.